The grade here climbs at 1 in 100 for 11 kilometers. In the winter of 1924, Locomotive 381085 was assigned a mixed freight working out of Frankfurt am Main. The consist behind it weighed 280 tons. 3 months earlier, this locomotive had been formally reclassified, not because it had derailed, not because it had failed a boiler inspection, but because the Prussian State Railway had designed it for something it could not do. It was built to haul express trains at 110 kilometers an hour. In service, the weight distribution was wrong. The driving rod bearings ran hot. The tender coupling rattled when running in reverse. Railway management assessed the riding quality and called it unsatisfactory. The design office target was downgraded by 10 kilometers an hour. And then the locomotive itself was downgraded, out of express service entirely. That was 1912. The locomotive class it belonged to would go on to serve German railways and railways across Europe for 68 years. Its intended successor, the BR-23, built after the Second World War specifically to replace it, was withdrawn from service 12 months after the last member of this class turned a wheel in revenue traffic. The machine that failed at its primary purpose outlasted everything designed to take its place. This is the Prussian class P8. Robert Garb was the Prussian State Railway's head of locomotive construction. He had built a reputation on simplicity. 2 cylinders, superheated steam, straightforward valve gear. No compounds, no complications. The P8 was his application of those principles to express passenger haulage. The boiler was effective. The superheating, drawing on Wilhelm Schmidt's thermal work, produced good steam quality. The 2 cylinders drove through Heusinger-Walchert's valve gear in a configuration proven across multiple Prussian classes before it. What Garbe could not fully correct was the weight balance of the reciprocating masses at speed. At 110 kilometers an hour, the forces were wrong. The ride became unstable. The maximum speed was cut to 100 kilometers per hour. Express services on the main routes demanded more. The Prussian State Railway began reassigning P8S to mixed traffic within years of delivery. Other German state railways, Baden, Oldenburg, Mecklenburg, watched and drew their own conclusions. After the First World War, 627 P8S were handed to the Allied powers as reparations. Belgium, France, Poland, Romania, Italy, Greece. Each of those railways expected to retire them quickly. None of them did. Before we continue, if this kind of railway history matters to you, consider subscribing to the channel. Every video here is built around the locomotives and railway systems that the standard histories overlooked. The machines that outperformed their celebrated counterparts, the engineering decisions that were ahead of their time, and the railway lines that shaped nations without receiving the recognition they deserved. If that is the kind of documentary worth watching to you, the subscribe button is how you tell us, and we want to hear from you. Did you work on the railways as a driver, a fireman, a fitter, a signalman, or a track engineer? Did a parent or grandparent spend their career on a railway that is no longer operating, on a locomotive class that is no longer preserved, or in a workshop that is no longer standing? Leave it in the comments. The people who actually operated these machines know things that do not appear in any published railway history. We want to hear from them. Now, back to the locomotive. The technical specifications of the P8 do not, on paper, suggest a machine of legend. 2 cylinders with a bore of 575 millimeters and a stroke of 630. Boiler pressure at 12 bar, 170 pounds per square inch. Driving wheels of 1,750 millimeters diameter. Starting tractive effort of approximately 12,100 kilograms force, and service weight in working order between 69 and 76 tons. It was not a large machine. It was not a powerful machine by the standards of what was being built elsewhere. The GWR's Castle class and the Pennsylvania K4 Pacific were both operating in this era. What the P8 was cheap to run, simple to repair, and almost impossible to wear out. The boiler's heating surface geometry produced steaming characteristics that crews described across 30 years of mixed traffic service as predictable and forgiving. A locomotive that would give back what you asked of it without demanding much in return. On secondary routes with variable load, 100 tons one day, 200 the next, that quality mattered more than tractive effort figures. The Deutsche Reichsbahn drew up replacement designs in the late 1930s. Material costs intervened. Then the war intervened. The P8 continued. By 1950, 38 years after its demotion from express service, the Deutsche Bundesbahn inherited 1,220 examples. The P8's operational record, assembled across multiple railway systems, is not a record of dramatic individual performances. It is a record of volume. Approximately 3,948 locomotives built across 13 manufacturers, 1,200 still active on the Deutsche Bundesbahn in 1950, 700 operating in the Deutsche Reichsbahn, East Germany, into the 1970s. The Polish state railways ran their examples, designated the OK1, through the same decade. The Romanian CFR Class 230 P8S, received as war reparations in 1919, were still in revenue service into the 1990s. 80 years of service life. From Henschel's factory floor in 1906 to a Romanian freight diagram in the 1980s. One documented unit of the Deutsche Bundesbahn fleet accumulated 3,719,271 kilometers before withdrawal. That figure is not a record. It is an average of what the class produced. Meanwhile, the Deutsche Bundesbahn had built the Class 23, the official post-war replacement for the P8, modern, correctly proportioned, designed with the benefit of 40 years of subsequent locomotive engineering. The last Class 23 was withdrawn in 1975. The last P8 on the Deutsche Bundesbahn, Locomotive 381772, was withdrawn on December 5, 1974. The replacement retired 1 year after the machine it was sent to replace. The P8 was never celebrated. No railway administration that operated it built a monument to the design. No major English-language railway history places it alongside the Gressley R4 or the Norfolk and Western J class as a machine that defined what steam haulage could be. It was a 460 that failed to do what it was built to do. That failure was its beginning. What followed was 68 years of unglamorous, continuous, dependable service on secondary and branch routes across Germany, Poland, France, Belgium, Romania, and Greece. 3,948 examples, millions of kilometers per unit. an operational record that no standard locomotive history published in English has assembled in full. Robert Garb built a machine for express haulage. He got the speed wrong and the balance wrong and the tender coupling wrong. What he did not get wrong was the boiler. What he did not get wrong was the frame. What he did not get wrong was the fundamental engineering of a locomotive that would prove adaptable enough to outlast everything the railway administrations of two countries tried to replace it with. The locomotive is gone. The class is gone. But the operational logs of 5 European railway systems contain the record of what those machines did. That is what the engineering record shows. And that is what this channel intends to document. If this is the kind of railway history you want to keep watching, subscribe to the channel. There are more locomotives, more railway systems, and more engineering achievements still to document. And if you have a connection to what you just watched, a family member who drove a Class 38, and worked in the workshops at a Deutsche Bundesbahn depot, or operated on a railway in Romania or Poland that ran these machines into the 1970s or later, tell us in the comments. What did they drive? Which railway, which depot, which line? The people who operated these machines are not in the standard histories, but the engineering record depends on what they remember. We want to hear from them.